Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. We're talking about stationary points and how to find the coordinates of the stationary point in this video. In the next video, I'll be talking about how to find the nature of the stationary point. Is that okay? So in this video, we'll be talking about how do you find the stationary point. And before we proceed, don't forget to like, share, subscribe, and click the notification bell so that when I post new videos, you'll be the first person to know. All right. So what is the stationary point? Just a if you have a particular curve, let's pick this curve. The point here, where the y over the x is equal to 0. Okay. So at this point here, the y over the x is equal to 0. This is our stationary point. So our stationary point, the y over the x is equal to 0, or you could have one like this at this point here as well. These are what we call stationary points. Okay. So what we call stationary points. So at stationary points, what is the key thing there is the point where the derivative, dy over dx, is equal to 0. So basically, from what I've just said now, you can now see that at stationary point, the first thing you have to do, you differentiate the equation, then you equate it to be equal to 0. Okay. So I'm gonna write it down because I know some of you do take notes. Okay, so that it will be easy for you. So stationary point. We're going to talk about stationary points of a function. Okay, f of x. Okay, stationary point of a function is a point where the derivative so when we talk about derivative, we're talking about the y over dx of that same function, okay, is equal to 0. All right, so that means what I'm saying is that a stationary point, so when you're talking about stationary points, okay, we're saying a stationary point, the y over dx is equal to what? 0. So what are we looking for in this video then? We're looking at the coordinates at stationary points. So what I'm saying is that now at this point, we know this point here, the y over dx is 0. Okay, we know this point here, the y over dx is 0. At this point here, the y over dx is 0. At this point here, the y over dx is 0, or at this point here, the y over dx is 0. So now, when we say the coordinates at stationary point, what we are asking now is that what is the x coordinate at this point, the y coordinate at this point for this curve, what is the x coordinate at this point, and the y coordinate at the point. So the x coordinate at stationary point, the y coordinate at this stationary point, or x at this point, y at this point, x at this point, y at this point. So basically, what we want to do is that we'll find the stationary point. After finding the stationary point, we want to now find the x at that stationary point and the y at that stationary point. In the next video, I'm going to talk about the nature of the stationary point, okay? But just for this video, I want to show you how to find the x and the y for stationary points, okay? So how do you find stationary point? There are 5 steps or 5 rules, okay? So there are 5 steps or 5 rules on how to do this. The first thing you have to do is that you have to differentiate the function to get the dy dx. So you can use any of the mechanism we've talked about. I think I've talked about 15 mechanisms there. So you can use any of the mechanism to differentiate. So you have to make sure before you come to this video, the first thing you have to do, make sure you know how to differentiate. And you've solved so many questions from the worksheet and you've practiced how to differentiate very well. So the first thing you have to do is to differentiate, because you can see what one of the most important thing there is that you need to find the dy over dx. That's why you're differentiating. You need to find the dy over dx. So we'll have to differentiate f of x, or some textbook we call it y, to get what? Dy over dx. Okay, so you use any of the differentiation mechanism. Okay, I've talked about several of them, so please go back and have a look. Now, the second thing as well, you see, what I told you is that at the stationary point, the y over dx is equal to what? 0. So that means stage 2, after differentiating, you then have to equate that derivative you got or the result from step 1 to be equal to 0. So then you have to equate the derivative or result from step 1, that is the derivative you got, to 0. So therefore, the y over dx is going to be equal to what? 0. So that is, so the answer you get from step 1, you equate it to what? 0. Now the next thing is that, so remember the key is not that we're not looking for the y over the x here. What we are looking for is the x and y at that stationary point. So what you now do is that because you've equated this to be equal to 0, you have an equation now. So you now solve this, the y over the x to be equal to 0, to get all the possible values for x. So stage 3 or step 3, you now solve step 2 and get the possible values for x. Okay, so for this curve, you're gonna get the curve, for this one, you can get, let's call this the x1 and you get the x2. Okay, so the first x at stationary point and you get the second x at stationary point, because this is one curve. In this, for instance, you might only get one stationary point for this curve. In this one, you might only get one stationary point at this curve. So you can either get one stationary point, you can get two stationary points, you can get as many depending at the point or the turning point of the curve where the y over dx is equal to 0. Now, when you found x1 and x2 or x1 or depending the x of the values, now the next thing is that you need to find the y. And in order to find the y, you have to now substitute this x into the original equation for each of the curves. So each of the curve has an original equation. Okay. So what you now do is that the x you found here, you substitute it back into the original equation to give you the y. The x you found here, substitute it into the original equation here to find the y. You substitute x1 into the original equation to give you the y1. Are you seeing it? And you substitute x2 into the original equation to give you the second stationary point. So that will be the step 4 now. You now have to put back each of the x values to get the corresponding y values. All right. Then after you're done with that, number 5, then because you've gotten the x1 and y1, you have to write it in the bracket form, in the right form. So the x1, the x will come before the y. So you have to write it like this. So the stationary point has to be in a coordinate format. So the x1, y1 or x2, y2. So in this, you have two stationary points. In this, you only have one stationary point, while in this, you have just one stationary point. Okay. So you can see based on the curve, so you can have one, you can have more than one, depending how the curve is. So now determine how many stationary points you're gonna have for a particular curve. So then number 5, you then write down, okay? You then write down each x value. With its corresponding y values. So you're gonna have, so you're gonna be like x1, y1, and you then have all x2, y2, okay, etc. So you're gonna write it in the bracket form, in the coordinates form. So we talked about coordinates before. All right, so let's solve a question now. All right, so let's pick a question and solve. So let's pick an example. So in this example, we're told to find the coordinates of stationary points of each of the curve. So let's say you are told to find the coordinates of the stationary points on each curve. All right. So let's start with the first one. We have y is equal to 2x squared minus 8x plus 1. All right. And you were told to find the coordinates at the stationary point for this. Very good. Let's go. Step 1. The first thing you have to do, you have to differentiate the function using any differentiation mechanism. So let's see. So we have y is equal to 2x squared minus 8x plus 1. We then differentiate it. The y over the x is going to give us, when you differentiate this, it's going to give you 4x minus 8. Okay, so please try as much as possible. Like I always say, go back and review the previous video. Okay, so please, especially on how to differentiate, is very important so that you know how to differentiate. Is that okay? Then step 2, after we differentiate this, we're told that we have to then equate the derivative or the result we got from step 1 to be equal to 0. So what we're going to do now is to equate this to be 0. So it's going to become 4x minus 8 is equal to what? 0. Or let me put it this way first. So at stationary point, we know that dy over dx is equal to 0. So therefore, 4x minus 8 is equal to what? 0. Then we go to the next one. So this is step 1, step 2. So we're going to step 3 now. So step 3, we then have to solve to get the possible values of x. Okay, so we're going to solve for x. So in some cases, you can get one value of x. In some cases, you can have 3 values of x, 2 values of x, depending the equation you have. So, but in this equation, we are just having 4x minus 8. So because it's a linear equation, you're going to have only one value of x, okay? We take 8 to the other side. So you're going to give us 4x is equal to 8. Divide both sides by 4. So therefore, x is going to be equal to what? 2. So we've gotten the x for the stationary point. Now, the second part now is that we then have to, because we're looking for stationary point, a coordinate, you need to have an x and a y. So to get a y, we have to put back the x value to the original equation to get the corresponding y. So we have to put back each of the x values I forgot to add into the original equation. So original equation. So the original one, the question you were given to get the corresponding y value. So the step 4, the original equation we had was y is equal to 2x squared minus 8x plus 1. Are you seeing it? Then we'll have to substitute x to be equal to 2 into this. It's going to give us 2 squared minus 8, 2 plus 1. And therefore, the y is going to be equal to minus what? 7. So the y value at stationary point is minus 7. Then we can now have step 5. Okay. So we have to write down each x value with the corresponding y value. So we have to write down that. So it's going to be 2. The coordinates is going to be 2 and what? Minus 7. So this is the coordinate at stationary what? Point. Okay. That is the coordinate at stationary point. Let me pick one more example and then we go to the next video. All right. So let's say we're looking for the stationary point for y is equal to, let's say, x cubed, let's say minus 3x plus 4. Okay. X cubed minus 3x plus 4. All right. So let's go. So the first thing, step 1. Okay. Step 1, we're told that we have to what? Differentiate. So let's differentiate this. So that's the reason why you need to make sure you've reviewed my video on how to differentiate. Okay. All right. So let's differentiate this. The y over the x is going to give us 3x squared minus what? 3. Are you seeing it? Now step 2. we need to equate the derivative we've got to be equal to 0 because our stationary point, the y over dx is equal to 0. So step 2, we know that the y over dx is equal to 0 at stationary point. So therefore, 3x squared minus 3 must be equal to what? 0. All right, so we're done with that. Step 3, we then have to solve to get the possible values for x. All right, let's go. Step 3 now, we need to find x. So step 3, we are having 3x squared minus 3 is equal to 0. I can simplify this by dividing both sides by 3 to make it easy. And we have x squared minus 1 is equal to what? 0. And I've told you, you can see now we have a quadratic equation and we need to factorize this. So I've showed you how to solve quadratic equations. So if you've not reviewed my video on how to solve quadratic equation, I showed you that one of the methods of factorization, we have completing the square method. We have difference of two squares using of common factors, trinomials when a is equal to 1, trinomials when a is not equal to 1, also using the formula method, okay? So for this one, it's a classical example of difference of two squared because I can rewrite this as x squared minus 1 squared is equal to 0. And I told you for difference of two squared that a squared minus b squared is equal to a minus b, a plus b, okay? So if you've not reviewed my video on the quadratic equation, please go back and review it. So now x squared minus 1 squared is going to give us x minus 1, x plus 1 will be equal to 0. And I told you that how you solve is that you have to then equate each of them, okay, to be equal to 0 to solve for x. So x minus 1 is equal to 0 and x plus 1 is equal to 0. So therefore, x will be equal to 1 or x will be equal to what? Minus 1. So you can see in this example, we have two values for what? X. Now the next one we have is step 4. All right, step 4, what do you do? So in step 4, we're told now we have to put back each of the values of x into the original equation to get the corresponding value of y. All right, so what we're going to do, each of this, we're going to put it back into the original equation to get the corresponding value for y. So when x, we'll start with the first one. When x is equal to 1, let me write down the original value equation first. So the original equation we had was y is equal to x cubed minus 3x plus 4. So the first one is when x is equal to 1. So y will be equal to, we have 1 cubed minus 3, 1 plus 4. So that means anywhere you see x, you substitute 1. So therefore, the y will be equal to, so when you press all this in your calculator, this is 1 minus 3 plus 1. That will be 5 minus 3. That will give you 2. So when x is equal to 1, y is equal to 2. Okay? So this is for when x is equal to 1. And when x is equal to minus 1, the same thing. Y will be equal to, anywhere you see x, you put minus 1. It's going to be minus 1 cubed minus 3 minus 1 plus 4. And when you press your calculator for this, your y will be equal to what? 6. So now we have to write this in the coordinate form. So the coordinate at stationary point will be when x is 1, y is 2, and when x is minus 1, y is what? 6. So that is the stationary point for that. So the first thing, you differentiate it. After you differentiate it, you equate it to equal to 0. You solve for x. You now substitute the value of x into the original equation to get y. Then you now simplify. All right, so let me give you some exercise to try, okay? Let me give you some questions that you can try to solve and see if you can get the same answer with your colleagues as well. All right, so let's look at this exercise here. So number 1, we have find the coordinates at stationary points. Okay, so I want you to find the coordinates at stationary points for this one. So let's say we have y is equal to 5x cubed plus 3x squared plus 6. We have y is equal to 2x 3 over 2 minus 6x. And number 3, we have y is equal to 9x 2 over 3 minus 4x half plus 5. So I want you to find the coordinate at stationary point. So as usual, like I always say, put your answers in the comment section or discuss with a friend. And if both of you are still struggling, feel free to email me, or if you see me around, you can just stop me and we'll discuss it, okay? All right, so that will be that for how to find the coordinates of a stationary point. So basically what you do is to differentiate it, equate it to be equal to 0, solve for x, then solve for y, and write it in the coordinate form. I hope this was helpful. Okay, now, so the next video I'm going to talk about now will be the nature of stationary points. So how do you know this stationary point, like in this case, is a maximum? The stationary point here, this coordinate you have here is for a minimum. This is for a maximum. This is for a point of inflection. How do you know? How do you get that? How do you solve that? How do you know, okay, this coordinate stationary point I've just found, is it a maximum stationary point? Is it a minimum stationary point? Is it a point of inflection? So that will be the next video I'm going to go to now. So that's why it's important that you make sure you subscribe and you click the notification bell so that when I post the next video, you'll be the first person to know. So I'll see you in the next video where I'm going to talk about the nature of a stationary point. So I'll see you soon.